So let's practice some problems. Which axis is the point 0, 4, 0 on? Well, this is a three-dimensional point. The x coordinate is 0, the y coordinate is 4, and the z coordinate is 0. So if we were to graph this, we can make a simple sketch, and we know that the 0 on the x coordinate tells us that we're not going to move away from the origin in the x direction. 4 tells us we're going to move 4 in the y direction, which means right. And then z of 0 means we're not going to move it all up parallel to the z-axis. So we now have a point on the y-axis. So you'll notice that when you're going to be on the axis, for example, the y-axis, the other two coordinates will be 0. You can notice here, I've graphed the point -2, 3, 0. So this point is 2 back going along the x-axis, and then it's 3 to the right along the parallel to the y-axis, and then z will be 0, so we're going to go up 0. So we lie in the xy plane, and the xy plane is that flat plane through the x and the y axes. Here we have the xz plane, and you can see it's like a piece of paper that's sitting on the x-axis and the z-axis. And clearly we are in front of that. At the xz plane, you can see y is equal to 0. And since our y is not 0, it's positive, it's going to be in front of that xz plane. And lastly, let's look at the yz plane. So the yz plane, the equation is x is equal to 0. And you can see that we are behind that because our x is less than 0. So our point sits on the xy plane. Which plane is the point 0, -2, 4 on? So if we graph 0, -2, 4, it's the green point. 0 means we don't move in the x direction. -2 means we move in the left on the y-axis, 2 units. And then 4 as the z-coordinate means we go up parallel to the z-axis 4 units. So we know it doesn't sit on the xy plane, that's flat. It's above that, and it's 4 units above that because the xy plane has a z of 0. Now that we're looking at the xz plane, we can see it's sitting behind the xz plane. And the yz plane, it's sitting in front of the yz plane. So when you're on the yz plane, you have an x equal to 0. Do you see the pattern now? That when you're on the plane that you're on, yz for example, is missing the x coordinate. It has a 0 there. And for the next one, it says, what is the x coordinate for every point in the yz plane? Well, we can say it's 0. So every point in that plane needs to have a 0 for the x coordinate. And I made one up. Now, why don't you try to name a point on the xy plane? So I made the example 3, 5, 0, because on the xy plane, z equals 0. Now name a point on the xz plane. I made one up, 4, 0, 3. Yours may be different, but yours needs to make sure that it has a y equal to 0. What is the equation of the yz plane then? Well, at the yz plane, every x is equal to 0, so our equation is simply x equals 0. What is the equation of the xy plane? Z equals 0. Is the point 3, -2, 4 located above or below the xy plane? Well, if we graph it on our grapher, it'll help us visualize it. So the magenta point is our point that we just plotted, and you can see it lies above the xy plane. And we can tell that because the z is positive. It's a positive 4. Now, let's look at the xz plane. You can see that we are behind the xz plane. So for this plane, we would consider looking at the y coordinate. And then if we were to look at the YZ plane, you can see we're in front of it. And for the YZ plane, we're looking at the X coordinate, which is positive. Now let's figure out how far is the point 254 from the XY plane. So we know the XY plane, if we were on the XY plane, we'd have a Z equal to 0. We would be 4 units actually above the XY plane since it sits flat. Let's give the coordinates of any point on the Z-axis. Well, we know that if it's a Z on the Z-axis, that means the Z coordinate has to be a number. So we want X and Y to be 0. So here we're going to give the coordinates of any point on the Z-axis. So we want X and Y to equal 0, and then we could give any Z coordinate. I'd use 6, but you could use any number you like. And finally, give the coordinates of any point on the XZ plane. Well, to be on the XZ plane, you'll have to have a Y equal to 0. So we want any point that has a coordinate of Y equal to 0. So I chose 8, 0, 4. And as long as your Y equal to 0, then you can choose any point. Oh, we have one more. Give the coordinates of any point on the plane X is equal to 4. So this is not on the YZ plane. Instead, it's going to be 4 units in front of that plane. And it's parallel to that YZ plane, though. So any point on this will have a coordinate in the X coordinate of 4. So I chose 4, 5, 6, but you could have easily chosen 4, 8, negative 2, or 4, 12, 0. Okay. Next, we're going to look at the distance between 2 points in 3-dimensional space. So we're going to do this just like we did it in 2-dimensional space. We're going to look for the distance between P and G using the Pythagorean Theorem. And we're going to do it twice. The first triangle we're going to look at is in pink. It's a right triangle. And we know that if we find the Pythagorean theorem, we can find that hypotenuse. So x minus a squared will be this leg plus y minus b is this leg squared is equal to the distance pf squared. And that's simply the Pythagorean theorem. Well, we can figure out the distance PF by square rooting both sides. Now we're going to do this again, looking at this green triangle, which is also a right triangle, so we can use the Pythagorean theorem again. So we know the length along the bottom of the triangle is going to be PF. So if we use the Pythagorean theorem, we'll square that side, which when we square PF, we'll end up with x minus a squared plus y minus b squared. That's my first leg. So now we're going to add on the vertical leg and square it. So plus z minus c squared, all squared. And this will equal the distance PG squared. Once again, using the Pythagorean theorem. So to figure out PG, I'll take the square root of both sides. And this is the distance formula in 3 dimensions. So it's simply taking the Pythagorean theorem twice. Let's find the distance between these 2 points, 3, 5, negative 2, and 10, 6, 4. So I'm going to subtract the x coordinates and square them. And I'm going to add that to the difference of the y coordinates squared plus the difference of the z coordinates squared. And then I'll take the square root of that quantity. And I end up with the square root of 86, which approximately is 9.3 on your calculator. We can use the distance formula to help us write equations for three-dimensional shapes. So let's find the equation for a sphere with a radius of 1 with its center at the origin. So let me sketch this up as best I can. And we'll be doing a lot of sketching this class this semester. And I know it's sometimes difficult, so we're going to get better at it. That's okay. If you're not a great drawer, we're going to work at it. Okay, so I drew my radius in as 1, and I labeled my center at 0, 0, 0. This was given in the problem. So the equation for the sphere is going to be anywhere along the outside edge, the shell of the sphere. So I'm just going to pick a point on the sphere. And I'm going to label it x, y, z. So now let's figure out the distance between these 2 points. So I'll say x minus 0 squared plus y minus 0 squared plus z minus 0 squared. And this will give me, when I take its square root, the radius, the distance between those 2 points. Now, if I want to clean this up, I can just get rid of those zeros. And I can clean it up even a little farther by realizing I can square both sides. And if I square both sides, I'll end up with x squared plus y squared plus z squared equals 1. And that is the equation for a sphere with a radius of 1 with a center at 0, 0, 0. Okay, let's try the next one. This says, find the equation for a sphere with a radius of 5 with its center at 4, negative 3, 8. So I'm using the same diagram, just relocating the origin to 4, negative 3, 8. Once again, I know the radius is 5 on this one, so I'm going to change that distance that I drew in yellow. I'm looking for the distance between those 2 points, which I can use my distance formula. So I'm going to say x minus 4 squared plus y minus a negative 3 squared plus z minus 8 squared. And this is going to be equal to, when I take its square root, the radius. Let's go ahead and square both sides. And when I square both sides, my right side becomes 25. And my left side becomes x minus 4 squared plus y plus 3 squared plus z minus 8 squared. And this is the equation for a sphere with a radius of 5 with its center at 4, negative 3, 8. Now, I'm going to point out that this is the shell of the sphere. It's not the inside of the sphere. It's not the ball. It's the edge, the outer edge. If I wanted to make it the inside, I would have changed it to an inequality. So this would be the area inside, the volume inside of the ball. But since ours is just the outside edge, we're going to leave it as equal.